Okay, so here's the video for section 12.6, surface area and volumes of spheres. To be honest, most of this is really just two formulas and kind of working out the two formulas. So we found surface area and volumes of prisms and cylinders. Now we're going to do the same thing for spheres. So a definition of a sphere. Okay, the thing is a sphere is essentially a circle but in three dimensions. So as a circle, you'd be set in a plane and you'd be at one point and you'd be the same distance away from it in a flat surfaced area. Well, now with the sphere, now you're doing this in three dimensions, so you're going all over the place. And you still have a radius. You still have diameters, you still have chords, you still have tangents, all those things hold. Radius is still the segment from the center to a point in the sphere. A chord still connects two segments, any points in the, I mean, connects any 2 points in the sphere. Diameter is still a chord that goes to the center, and a tangent is a line that intersects a circle, or sorry, sphere at exactly 1 point. So it's basically a lot of the same stuff as a circle, just in three dimensions. Um, Now, like I said, for the formulas, it's really just two formulas, and even those two formulas, I'm pretty much just going to have to give them to you because the explanations we give are really kind of blah explanations, and the easiest ways to kind of sort them out requires calculus. So for the surface area of a sphere, it's 4 pi r squared, and that's about it. So 4 pi r squared. For the volume of a sphere, 4/3 pi r cubed. Again, there are ways to kind of prove this, but it gets to be too complicated. If you take calculus in a few years, you'll learn it then. If not, I don't think your world will be any less fulfilled. But 4/3 pi r cubed. The key, though, to keep them straight is squared gives us surface area. Cubed gives us volume. And notice there's 4/3, so it's over 3, and this is a 3 here. Um, so that's kind of the way to keep track of those. But I mean, really, it's just brute force memorization. Another thing too that's going to come up for section 12.7 is talking about three-dimensional spheres and kind of like plane slicing it. Plane can intersect a sphere at a point or in a circle. If you hit if the circle contains the center, we call this a great circle. So here's one where it's not going through the center, it's just a regular old circle. This one's going right through the center, so it's getting what's called a great circle, and that's the biggest circle possible. The endpoints of a diameter of a great circle are called poles, like the North Pole up here and the South Pole down here. And if it cuts to the center and cuts it in half, we get what's called a hemisphere, which is, again, these really the hemisphere you should be familiar with. But in poles, you should be familiar with. Might not have thought of it though with the circle. But again, we'll expand upon more of this in section 12.7. So, first example, find the volume and surface area. Now, for this one here, it's not, hey, here's the radius and go with it. This one they've given you the circumference, so we're going to have to work backwards. Okay, so let's take a look then. Alright, so you've got the circumference is 8 pi. Now you have two formulas. Surface area is 4 pi r squared. Volume, 4/3 pi r cubed. So our real goal is to figure out the radius. Now in order for us to do that, we have to recognize that, oh, I have the circumference. And circumference is 2 pi r, or pi d, but didn't have to divide by 2. Doesn't matter either way. So 8 pi equals 2 pi r. I cancel off the pi's. I divide by 2. 4 is the radius. Okay, so great. We're good. So the surface area, 4 pi times 4 squared. 4 squared 16. 16 times 4 is 64 pi feet squared. Okay. Volume is 4/3 pi times 4 cubed. Now, unfortunately for us, 4 cubed is 64. That is not going to cancel the 3. So best we can do is 4 over 1 times 4 over 3 times 64 over 1, which gives us 256 over 3 pi feet cubed for our volume. Okay. And then next example, find the volume and surface area of the hemisphere this time. Okay, so for this one we've been given the diameter. That's the key to recognizing here first, is I don't have the radius, I have the diameter. Um, so if the diameter is 6, the radius is 3. Now the other problem is for the surface area, we've got half of a sphere. So it's 4 pi r squared, but only half of it. But that only takes care of the outside stuff here. It does not take care of this extra circle we've also got to look at. So I'd have to add an extra pi r squared on there as well. And what ends up happening is, for surface area, we can actually condense this down. 4 pi r squared over 2 is really 2 pi r squared, plus the other pi r squared for the circle. Surface area of a hemisphere is really a shortened formula of 3 pi r squared. The nice thing is for volume, you just take what they give you and divide it by 2, so it's easy to do. So in our case, we'll do surface area real quick first. It'll be 3 pi times 3 squared. Well, 9 times 7 is 27 pi square feet. For volume, we are 4/3 pi r cubed, but again, I only want half of that because I don't want to take the whole volume of the sphere. So that's going to end up being 1/2 times 4/3 pi times 3 cubed. Okay. Well, 3 cubed is 27. That's 9. It's 2. 18 pi feet cubed for our volume. Okay. Nice short video for this section. Yeah, here we go.